Hi guys, this is my partner here. His name is David. I'm Gerard. We're going to be explaining a little bit what is going on and some of the project we've been working on. And he's got his idea into it, which is very good at the point in time, because he's filling up a lot of the little hole I had in my stuff. And so we got something here who actually can literally run by itself and be able to produce a generator which can actually produce energy, so you can actually put a load on it. In other words, a house or anything else on it. And it's a self-running, so that's mean we're developing a primary mover who runs by itself. Without a primary mover, you can never get any free energy. So, but now I'm going to let I'm going to let him talk, and we're going to give you an explanation and how it is. And he's much better at me at explaining. his accent is better than mine. So go.
All right. This is going to be a concept demonstration. The reason is because proof in seeing is far better than words spoken. What you have to understand is the concept that we came through with and what we've designed is a primary mover, as he stated. If you were to go out and look on any street corner where the power lines come in on telephone poles, you'll notice in front of the house there's a 5,000 or 5 kVA can out there. We call it a transformer. It puts out 50,000 watts. Your house is wired, in the Americans' houses, they're wired at 120 on each side with 100 amps on each side. That's 240 volts times 200, it becomes 48,000 watts. 50,000 coming in gives you 48. Most all of us only care about one thing, and that's when we turn the switch, the light comes on. The appliance works. We want the power. The primary mover on that transformer is a wire. The wire is this diameter, and if you can see my finger, you can exactly see how big it is. That wire delivers 14,400 volts to that transformer, or 720 if it's only a single leg that is only 120 volts. I don't want to get into the calculations because that'll waste your time. Just look at this wire and understand this is the primary mover. This is where the power comes into that can that gets decimated in that can and segregated to come out to your home, to your panel box where you get your power. We're replacing this wire. What we're doing is we put together a system that'll fit on a 4x6 pad of concrete with a tiny shed on it. It has one of those 5 kVA cans on it. It has a primary mover, which is this motor, or a similar one, which is wired circuit-wise to run itself, because there's more than one pole obviously on this. There are 36 poles on this thing. When this actual unit is running, once it's kick-started, it will run itself because the feedback off one of those lines, one of those sections, is enough to run this motor. The motor is sped up and run to a specific RPM to generate through the generator the power we need to go through our wire to the transformer. We're developing the 14,400 volts. Now that's going to sound scary to some of you when you look at that and you're going to say, oh my God, you could fry somebody. Yes, you could, except for one thing. If it's put together with the proper installation and the safety packages on it, which is what we're going to do, a child could be beating on it with a golf club and it will not shock that child. In fact, the child can never become a load because of the frequency and modulation of the power we use. We use something called resonance frequency. Some people call it RF. In layman's terms, some people might even think of it as radio frequency. In a way, it's all of that and then some. When you understand the concept of how this thing works, which we're going to demonstrate with this light here, this light is an industrial light. This light right here needs 240 volts at 2 amps to run full bright. In a minute, my partner's going to turn this thing on with an awful lot less. When you see that, you're going to understand what we're doing conceptually. You may not understand how it physically works. That doesn't matter. You need to know it works. And that's why this system will work. Now, when this thing is turned on, this motor is not self-generating, but we will generate that motor.
I'm going to give him a shot so they know
Yes.
exactly what the number look at.
If you can read that, if you hold it still, you'll see it's 240 volts at 2 amps.
There we go, we got it. Right, so that's mean this driver is a multi-volt driver, so you need a minimum at low volt, at 100 volt to operate. You need minimum 2 amp to run. That's what his rating is. So, and this is an electronic driver.
Okay.
So now I'm going to push probably around about 32 volts.
Let me finish. Before he puts the voltage in here, please understand something. We have 3 components to this unit. We have the transformer, which really isn't a transformer, but we don't want to get into that. But it's a 5 kVA can. Let's just call it that. It's an off-the-shelf something that we can buy in quantity and get the cost extremely low. The motors themselves are also off the shelf, but they're wound the way we want them. These have been individually wound in a technique that is not used on the market today. It's how it's used, and how it's wound is how it uses the power that we put into it, which is completely different than the normal practice for these motors. Same with the generator, and same with the motor. These have been wound a specific way. When we have these wound in a specific way that we need them, according to specifications, in quantities of 1,000 or more, that cost too will go down. Because automatic winders don't care whether you want them right-handed, left-handed, or start in the middle and go backwards. It doesn't matter. An automatic winder is an automatic winder. You're paying for time, materials, all that. That's it. It's the same cost to make it our way as it would to make it the same way they've been doing it the other way, because it's all done with an automatic winder. The generator is the same way. When you put these 3 components together, you've got a primary mover, which is the motor, operating a generator, which generates the power, which is the primary mover for the can. The output of that can is going to be exactly 120 volts each leg, 100 amps. Those 2 wires go into the house, they hook to the panel. Now if you have it hooked up to the service, and I'm talking about the electric service that normally feeds your house, the power that you're not using can be actually sold back to them. You can actually cause this thing to pay for itself eventually over time, in countries that allow it. Now, let's talk about countries. This unit is being designed for the American market. It does not have to be designed for the American market. Overseas, a lot of countries use 220 volts at 200 amp. It's a single line. They don't have double lines. It's more efficient. They get more usage out of their appliances at 240 than we do at 120. But this unit can be driven to do exactly the same thing. We don't have to change a thing. We just change the transformer. And those transformers are also off the shelf and extremely inexpensive. I told Joff at one time when he questioned about what this thing would cost, I said $15,000 because I wanted him to think of it as an expensive thing. Not because it really is $15,000. When we get through with this, with the buying power that we expect to have, we should be able to produce these things completely out the door and make a profit on them at $7,500. Now, in America, if your average bill was $200 a month, let's say $100 a month, $7,500, 75 months, it's paid for itself. Then from then on, you're on what we would call free power. Free power, regardless of whoever says it is not free. You have to pay for something, because then once you've got it paid for, whether it's solar panels or windmills or whatever, once those are paid down by the savings of not paying that power bill, it becomes free power. We have designed a system that is free power. Now, he's going to demonstrate the lamp that you just saw. He's going to run a 240 volt 2 amp light with 32 volts. Now, if you took a physicist or electrical engineer, which I am, and you had told me that was going to happen, I would have told you you're full of shit. It can't happen. You can't put in less and expect more to come out. It doesn't happen that way. Yes, it does. When you don't understand something, you're ignorant of it. We're all ignorant of something. We're not God. We don't know everything. We are ignorant of the fact that we do not know, and we haven't known, that the collapse of a sine wave is where the energy is. It's not in the sine wave. It's not in the peak or the squareness or the valleys. It is in the collapse of it. This is resonance frequency. When resonance frequency happens, you have a throughput of the actual voltage necessary to operate the mechanism. Heat is done by amperage. He can show you a light bulb that he damn near burned completely in half at the base. The cement out of it is completely melted. And he was using very little voltage at all. But it drew the amperage. When you run these things on what the proper voltages for them to operate, they run cooler. They don't destroy themselves. They use less energy to operate. They're cost effective even because they're operating at their maximum efficiency. When we're making this power, it runs through the house with the same intensity, if you will, and the same capability. But the delivery is much cleaner. He will explain the difference between 30 cycle, 60 cycle, 120 cycle also. This cycling is for our benefit. It's for our eyeballs. And he'll explain it better than I do. But basically, let's put it this way. Under 60 cycle, you can actually see the lights flicker. Somewhere between 55, I think.
Yeah, between 50 and 55 you see flickers.
You can see flicker. Below that, you'll always see flicker. Above that, you don't. That's what the cycle's there for, is to keep us from perceiving that flicker. It has nothing to do with the power.
Well, it's got something to do with the motor,
Yeah.
because the motor on a rotation.
But when you start using that cycling for the motor, it makes a big difference. All right, I'm going to get out of his way, let him demonstrate this thing. Watch it, and like I said, you will not believe what you see. But this animal right here, this light, has only 2 plugs to it. Everything laying on this table is completely and absolutely unwired. You can see me picking it up. The only wires on this
the power supply.
are the power supply from the oscilloscope.
That's DC power, right? From this power
You
supply
can
here.
see it right here. It's coming straight out. There's no hidden wires.
And you will be able to see the amperage and the voltage going into to the unit as I'm driving it. So let's get this thing plugged in.
He's going to be driving the motor, which drives the generator that will power this light.
Yeah, the generator is this the little guy here, the internal working, and the motor is the external working one. So I'm going to put, so we got all our, those are extra wire I pull out. I rewind a couple of legs there. I had extra legs, so I decided to see how much voltage I can get out of that. And so far, if I can get my RPM up to 3600, I should get about 68 volt out of that, you know, which I can literally dump back into my controller
And self-generate.
Self-generator. And I'm going to give you a little torque when I'm running this light. I'm going to put, because now I'm putting a load on it, like every generator, right? So let's see, we're going to start this thing. Alright, hold on, yeah, we're going to bring it up to, alright, that thing is a 40 volt. I like it running around about 44, 45 volts.
He's talking about his controller. This
I'm
comes
talking-
out of a
yeah.
little slot car.
Look, that's just a tiny little controller for an RC car or an RC plane, whatever you want to use it
Yeah.
for. Right?
It's a radio controlled.
Radio control. So what I'm going to do, I'm just going to plug it in so I get my control working here.
Now he's got a set of batteries here.
Yeah, that's
4 8 double A's.
yeah, four double A, so I get 5 volt to energize my control, my speed control. That's all it is. See, normally the power comes from there, but this one, for some reason, the high voltage didn't have the power coming in. So, but that's nothing. You will see, right? Now I'm going to energize this whole thing up, right? So I'm pushing 44 volts. Okay. Come on. There we go, close enough. And I have 0 amp, right? Because it's just not doing anything. So I get 0 volt on that one.
Now before you go any farther,
I'm going to bring the camera back where we're supposed
Yeah.
to. I forgot that. Sorry, guys. We've been talking and not paying too much attention to what we're doing.
all right.
All right. Now we
Now before he starts, he's got 40, almost 44 volts ready to come down through the controller to start everything.
Yeah.
He's proving that he has no voltage on it right now because he hasn't allowed the switch to go through yet.
That's right.
He is battery operating that controller right now.
No, I'm
the
just
speed controller.
The speed controller itself, right?
And now you'll turn it on.
So you will see it doesn't want to start. See, you have a memory problem in the starting, right? It's because it's the timing on those things is not quite right for that controller, which I will explain you later on. But let's get this thing turning. It's very quiet, and you see the light. Now, I'm pushing 32 volts,
Hold it up so they can see it.
right? 32 volts.
That's it.
That's it.
32 volts is all that you're getting out of it.
Now I have a load on it,
And there's the light.
and then you see a little bit of flicker in there, right? It's because this power do not recognize rectifier.
Yeah.
Because it's not AC power. It's RF. So now I'm gonna do a small load test. I got a load, right? Now I'm only pushing this motor only about a quarter to what the power I'm supposed to push in on it. So it should be really weak. I should be able to stall this motor and not hang flat, right? I'm gonna slow it down. The power will go. But you can't stop this thing. You try.
No, I've already tried it. It wouldn't work.
It's just like, and look, do it again. Look, we're only pulling 4. Well, now you finally got it, right? You finally got it.
It hurt. It was hard.
But can you imagine? I got those motor here, which they're 500 watts, right? They're starter motor. They're four magnet, 4 brush, right? They're supposed to be rated to run about almost 20 horse, right? And you can stall it with your finger.
Yes.
I did that in a mini video. I thought he had lots of power, but they
No.
don't. And he used so many amp. I mean, he shoot my volt, my
Go
amper.
back to what we're doing. You put on less than 44 volts. He started this motor, and it has enough torque, even running this light, that it's so difficult for either of us to try to even stop it. It was ridiculous. I had to use everything I had just in my forearm strength to push it down to stop it. And it's only running at roughly what, 1200?
No, at 1100 RPM.
1100 RPM.
And I'm only running at each line here, I'm only pushing it roughly around about 18 volts.
So, when we're running, as you can see, and this is the over unity problem that I wanted, explanation I wanted to say, we're using 18 volts per leg, but we're driving out enough energy to run this lamp.
That's right.
That is over unification. We're putting in less than we get out.
Especially when you see the amp. Look at the amp driving this.
It's not even one full amp.
And I'm driving a motor, a generator, and a light.
So, our proof of concept is this. We know by doing the windings that we do, by setting up the caliper that we do, by arranging it the way it's set to work, we're driving pure force through to the appliances. An energy that can be utilized and consumed properly. The last thing that you have to look at is that the reason why we came to you in the first place for the money is this right here.
We need to replace this here.
That controller, there's not a controller on the market that will do what we need. We have to design it ourselves. We know exactly the algorithms. He's already designed the algorithms. We know the components that we need. We know how we want it done. For the security of the unit, it has to be built in 3 sections from 3 different sources, arranged and coupled and put together, and then that unit needs to be epoxied in and closed off where it can't be taken apart. Because quite honestly, that's the reason this thing works.
And we don't really have to worry about protecting the idea, because all my IP is already been protected.
Okay, what he's talking about is his intellectual property, his international patent of property rights are visible because he's already exposed them onto the YouTube on a lot of things, and that is his protection for a lot of his stuff. But in this particular case, he has no protection against companies in China and the Chinese in general, because he could go upstairs and get you a popular mechanics magazine that's like 30 years better old. It shows a variety of motors that have been designed over the years, over that period of time. Every one of them have been taken by the Chinese and replicated. Everything we do can be replicated and done very well by them.
And also done every time, every single time.
Every time.
Yeah.
But the controller is the only thing on this entire situation that you will never know how it works. Quite frankly, I don't want to know how it works either, because I do know how it works, but I don't want to know the algorithms and have them exposed, because those algorithms are what make this thing work. That controller is designed because, like I told you, this has been rewired and wound differently. The motor, the generator as well. Because of the way it's done, that controller is able to put out the proper voltage as it's designed to do so, to run this generator here the generator itself has to be run by this motor at 3,500 RPM to get the voltage out we need. Once that voltage is protected and into the can, the end result is you turn the light switch on and your light turns on.
It's back to normal.
It's no different than if it was on the power company. These units can be shipped all around the world, everywhere you can think of, and can be sold to anybody that wants to be off the grid permanently and for a reasonable price. I know that with proper purchasing, which Geoff is quite good at, we can get our costs down and to the point where we can produce these things at a reasonably decent profit, right around $7,500. That is an incredible buy for somebody that owns a home. Because obviously in America, where you've got $200 bills a month average, 37 months later you're free. I mean free. Off the grid, no power bills ever again.
And no gas bill and no any other energy going into this.
If you're totally electric, you're on electric. Now, one other thing, there's two more concepts we need to bring to the table. These systems are designed to produce a power source for a minimum of 25 years. I say a minimum because of one reason. Every bearing in the world that's not made with a round bearing, a really good round bearing, will destroy itself. It's built to destroy itself over a period of time. They do that because of one reason. They don't like not having sales. Nobody does. But if we put the right bearings in these things that are properly made, and we can have them made, by the way, very reasonably, these bearings that I'm touching right now, over 35 years old.
Yeah.
Over 35 years old. And they run at over 5,000 RPM.
But they're good grade.
But they are American-made, good grade bearings that were specifically built a long time ago to be bearings. Nowadays, they build a bearing that will wear and gall itself over a period of X number of hours. They want operational hours so that you have to replace the bearing. These don't get replaced. If we can have these manufactured the way we want them and placed on our motors and our generators, you've got a unit that could last forever. 50 years, not a problem. There are three things that will destroy this. Heat is the first. If for some reason either of the units got overheated, the annealing on the wire would eventually melt and deteriorate, and then you'd have a cross phase. Second, tampering. Deliberate tampering. Third is an act of God. An extremely high static charge, like a lightning bolt finding its way through the top of the roof and into it. Those are the only three things that can destroy this. How do we keep heat away? Well, that's an interesting question. I'm going to let him explain to you how things actually cool when you add load to it, because it's an exciting story.
It's just the drum motor, I call them the drum motor, and that's more likely what it is, a drum with magnet, and they spin around the stator. Is if you put the right frequency into it, and when you put a torque into it, what's happening is the torque increase and the amperage decrease to a certain level. But if you put your finger on the side of the winding, soon you put the torque on it, you can feel the drop of temperature actually to make your finger cold. Now, I mean, I have friends they're been in electronic and electrical for a long time, and they agree with me. They said if you can run anything above 800 volts, they said everything would freeze. The coil would literally freeze. Now I want to show you guys something, just for the hell of it. They don't create heat much because you cannot burn an RF generator. And for the reason I'm going to show you, I'm going to start it again, right? And normally in the normal world, a generator, you put the two wires together, you get like 10-15 seconds before the smoke. Now I can take off from here and I can go to town, do some groceries and have a coffee and lunch with the boys and come back 4 hours later, and that will not heat up.
Stop right there. Now, remember what I said, the first number one destroyer of these machines is heat? The reason I did that is to show you, again, concept of proof of concept. That damn thing's cross-phased. You can't cross-phase any generator you know without it burning up in 10 to 15 seconds. This is totally cross-phased. I'm pulling this out of the way. You see the wires right here? If you don't believe it, we can take the wires off and cross-phase it.
Yeah. I mean, I can just do that,
Go straight.
and I can go here. Here we go.
There you go. We're cross-phasing a generator. Gentlemen, that doesn't happen in the normal world of physics. If I had a physicist here, and he's had a couple of them here a couple days ago, they looked at that and went, this is impossible. It can't work. According to the rules and regulations they've been taught, you're absolutely right. But when you look outside of that at how actual power is generated in the actual frequency or resonance modulation, when you understand how that works, that dynamic is what's allowing us to run this thing, as you can see, for more than a minute and a half. It's not burning up. So our first part of our guarantee is that it can't burn up because of what? Heat. This generator won't overheat itself ever.
And you can see how small my wire are from the generators. There's 21.5 gauge on the wire I use for winding that system. And it doesn't heat up. You don't need big wires. This one here is a 32. I can put 5 amp load on that 32 of 5 amp of capacity of that wire, and it doesn't get hot. So nothing really gets hot when you stay on an RF.
Because the frequency doesn't impede, use the impedance of the wire as a resistance. That's why. We're not, for some reason, this frequency actually goes around the wire. More or less kind of like another skin. Transmission through the wire, yes, but it really is outside of it. It's like it's using the wire as an antenna, if you want.
An antenna or a rail to go someplace.
Yeah, rail, right. Bottom line is, when you look at how that concept works, that's why we can put those significant loads on a 28 gauge wire and not burn it up.
Maybe we should explain exactly what everything is happening.
Go ahead.
Here's the wire, like we'll show you again the wire with my thumb beside. That's what brings the power into the can. It could be a 25 kV, it can be a 50 or 75 kV, it's all the same size wire. But one thing I really look at when I took those can apart, because I take everything apart, right? Everything, oh, it's going to blow. No, just take it apart, right? And when it was connected to the end, to that big insulating horn, the other wire was this little guy here, a 16 gauge wire.
I'll stop right there. That's inside a 5 kVA can.
No, 50 kVA.
Oh, 58 kVA can. I'm sorry, a 50 kVA can. The insulated copper, which is bringing the wire to it, goes through the bus bar. From the bus bar, it transfers to that 16 gauge wire.
And that's what runs your whole transformer and your whole building at 50 kV. That's a 50 kV. That's a huge farm.
It's a huge amount.
It's a huge amount of power. That's 500 amp constant.
500,000 watts.
Yeah.
So 500,000 watts going through a 16 gauge wire. Folks, this is what we're trying to prove to you. We people who have electricity in our homes, we don't understand it. We're ignorant of what's actually happening. What's happening is we're being charged for something that is actually being manufactured right outside our doorstep. You see, the power that's going into that can isn't the power we're using. It's the manufactured power that comes out of that transformer that runs our house.
That's what you call AC. See, anything coming up from the transformer, the pole transformer, is AC. Anything else going into the pole transformer is called it's a transmission line, high voltage transmission line.
It's DC.
Well, some is DC in the state because you guys still using a chopped DC, right? But that's very nasty.
Oh yeah.
And when it's very nice, a lot of people get killed just throwing the switch on because it will jump 6 or 7 feet on you. So it's.
Let's get back to the safety issue.
So, and as you know, this thing is still running.
And the wire is not burning, right. It's not hot.
And I mean, we have to understand those wire is 3 brains of wire. That's
3 strains.
3 strains of hair size of wire, tiny little wire for electronic, not for a generator.
Now, again, before you would put your money into a project, you need to see its proof it's working. I can write a business proposal till hell freezes over. It's just words on a paper. What I wanted you to see is why it is viable, why it works. We need the money to build that controller. We're willing to give up 25% of the company for it. That money will build our controller. Once that controller is built, because of the way it's designed, it will be impossible, hopefully, to replicate it. The key to this thing is that controller. once we have the controller, there is a huge market. Now here's what I want you to look at, please. Gerard, step back for just a second.
Sure.
Look at this thing, 6 times this size. Gentlemen, we just put it in a bus that doesn't need any wires to go anywhere ever again. This is your public transportation, clean and free. This has enough torque, if it's built with a couple more modifications to it, I can throw this into a Komodo Dragon bulldozer and push a larger dozer on its back. This thing develops so much torque, it is unbelievable for the amount of wattage that's in it. Understand something, this application isn't just for making power for homes. This application is built for one specific purpose. It is to use the applied energy that's given it, amplify it to an extendable, calculable mass that develops enough torque to work. Now he showed you 20 horsepower motors that you can stop with your hand. This thing isn't even operating at a full horsepower, and it's damn near a bitch to stop. At what it runs on its automatic, you try to put your tie gets in front of it, it's going to strangle you to death and beat you to death at the same time. You're not going to get away from it. This small motor could develop enough torque to run the average John Deere tractor. Now you're starting to see where this can go. This is what we're bringing to the table, and this is why we need your money. We need this built so that we can develop the motors the way we want them, to develop the amount of torque we want them. The applications, gentlemen, here is unbelievable. Now don't start thinking this needs to be into a car and it become an electric car. There are a couple drawbacks with that. I don't want to get into it on this video, and if Joff and you people want to sit down with us, we can meet in Canada with Gerard and we can sit down and have a comfortable talk about it. We explain why it won't work in a car. The key issue here is this. It will work in larger vehicles because there's enough room for them. That's the issue. Okay? The issue is that you have to have the proper transformer. You don't use a 5 kV can or a big transformer. You have to have one designed specifically for it that gives out the voltages and wattages that we need to run the electric motors. You need a space for that. On a bus, you've got space for it. On a large truck, you've got a space for it. Think of all of these heavy, huge transport trucks across the United States and Canada, in fact the world, that don't use any gasoline or diesel.
No pollution.
No pollution, and can pull the entire load and not slow down. When you're looking at being able to pull a load because you've developed enough torque that the transmission can convert that to axle foot-pounds of energy, you're saying something. That little engine right there at 35 horsepower, at 3,500 RPM, you couldn't stop it if you had a belt-driven chain fall that you could actually attach to this that would be kind of like a slip collar, and as you put more strain on it, it slowly constricts and grabs. It would burn it up before it ever got to the point where it could actually lock onto it. There's so much torque on that engine right there, I literally could probably pull 20 tons off the floor with a pulley system, cable system, saddle pulley system, a single shim, not one, not three, not four, not 5 shims on the pulley, one shim. That little motor will pull 20 tons off the floor. Please give that concept some thought.
I mean, we can throw them a few things there. Just for example, those are the motor I work with, right? Which they're a large drum motor. They're for a washing machine, right? But I talked to the Maytag because I phoned the Maytag. I was working on another project, and I phoned the Maytag in the States, and he didn't know I didn't have a license. So he started talking to me like I had a license for Maytag. And then we were talking about the induction stove because that's what I was working on. I was fixing some problem. And then after that we started laughing at the induction stove because I found the problem. It was just they didn't put a ground in one place. And we started talking about those motors. And I asked him, I said, you guys playing with those motors, drum motor in your washing machine? I said, oh yeah. He said, those things are like crazy. I said, how much power can you, I said, how fast can you turn it? He said, to destruction. He said, to destruction. He said, how much torque you pulling out? He said, the drum you have in your hand, he said, 500 foot-pound torque.
Now, stop right there. When you drive a motor to destruction, it means that it's gone past its capable survivability RPM-wise. If a motor reaches that point, it is almost the point of being self-driven because it won't shut down. And it will destroy itself within a matter of a few microseconds thereafter. If we drove these motors with if we rewound these things, now this is just standard, he's getting the 500. He's not telling you what he can get when he rewinds it. Trust me, if you've ever heard this story, it's too damn good to be true. If he tells you that, you're going to run screaming in the night. We're not going to tell you, okay? Let's put it this way, 500 foot-pounds torque, you can move half the world around, okay? Leave it at that. When we put the torque on it that it can do, we'll be driving 20 megawatt generators, 60 megawatt generators, 120 megawatt generators without a friggin' problem. Yeah, we can build that motor, that little motor, to drive a 120 megawatt generator. The foot-pound of energy required is massive. The drive shaft on those damn things are 12 inches in diameter. They're high tensile strength steel. That motor, wound the way it's supposed to be, will not burn up, and it will deliver enough foot-pounds of energy to turn that thing at 3,822 RPM, 25 RPM, and it will develop 120 megawatts of power. When you look at those concepts now, this is what you're getting in with us about. This is what we're doing. We're the driving force, we're the primary mover for building energy devices, yes. But the key issue isn't the device itself. The key issue is in the motors. I'm going to stop this tape for a second. We need to take a phone call. Thank you for allowing us to interrupt this. We've been leaving this run since we've been off camera. You can look at the timestamp. It's only been a minute or so. This thing is still running, and we haven't turned it off, by the way. Does that prove to you that we know what we're talking about?
Smoke is not coming yet.
We haven't burned the generator up. I'm going to have him hook up the lamp again so that you can see it's still operating.
Absolutely.
We haven't lost the generator. The generator is still operating. And the reason why I'm doing that is to prove to you that we haven't switched out a generator or anything like that. There's your light. Everything's there.
So, and now, I mean, this is what is happening. I mean, like, this is another motor I'm building for the heck of it because I had it in my hand. I rewind the stator. I found the stator was 12 legs, which is perfect for my RC controller. I rearranged the wiring, and matter of fact, it's a very tricky wiring I did on it.
Don't necessarily.
I know, but it's just tricky. It's even tricky for me. I had to do this thing 3 times to get it right. And when I get the magnet,
with an automatic winderer, he won't have to do it. Believe me, it's simple. Trust me, it's an easy process.
So this small motor here is about 4.5-inch drum on it, and with the winding I did on it, and it's very little winding as you can see. With the right magnet in this thing, I will be able to pull 15 to 25 horse out of this motor. We're talking about 15 to 25 horse, not at full rotation. Those motors, they give you the horsepower and the torque at gradual rotation or at full speed. It doesn't make no difference. But this little guy here
delivers it at start.
It will deliver enough power, and way better power than a 25 or 20 horse motor for a race bike. And it will be a lot faster because I can spin this sucker 15 to 18,000 RPM. You can't do that with a motor.
What he's talking about is now replacing little mini bike motors with a power pack that'll give you 4 to 6 hours driving time. Why? Because the horsepower is in that 4-inch diameter motor. This is unheard of, folks. They don't, no physicist, I swear to you, get the best engineers you can call and say, I've got a little 4-inch drum motor. Can I get 25 horsepower out of that? 25 horsepower?
And the nice thing is, it's going to run for probably less than 2 amp at full power.
I want you to look at this. That is the entire insides of that motor. That's every coil in it. There's only 12 of them. You can see the thickness of them. There's my finger. You can see how far my finger went. See, look, that's it. Pulling my finger out. That much, that's the depth of those coils. What you're trying to say to yourself is, and you should be, these guys are either blowing smoke up my tail or they really know what the hell they're doing. We know what they're doing, because this will deliver 20 minimum, more likely closer to 30. He says 25, but it's going to be more likely closer to 30 on a good bearing. You notice that thing spins?
The good old Japanese bearing.
Guess what? There's no tension and there's no adhesion on the walls of those bearing sides inside. They were built German style with close tolerances. That's why it spins freely. You put 30 look, just put 20 horsepowers on that. 20 horsepower. Do you know any motor that is 20 horsepower on the market today that's that size?
And it will run on probably 72 volts and less than 2 amp at full torque.
They can't do it. You have, by luck, because of Josh and my association, come into a situation where the spin-off businesses from this are tremendous. And there are some things that we are working on right now that we'd like to eventually get some more money into that will be more impressive. Right now we need your commitment. We need your commitment to build that controller. Whoever we go to, we know that we can get the controller built to our specifications on a trial basis. Meaning that once it's built and it works, we have to be able to submit our credentials for a commitment. In most cases, from the manufacturers that we've talked to, myself and my partner, they all want 1,000 controller commitment. That's fair enough. I mean, they put a lot of time in these damn things and money to develop it using our algorithms, our wiring schematics, our potentials, and our magnet strengths. Okay, this isn't done by smoke and mirrors. They build the damn thing, we try it, it works the way we want it consistently. We do a burnout test, maybe take 2-3 months of hard work, constant on-off operation, constant on operation. We make sure that the heat sinks deliver the dissipation of heat that we need. We make sure that the loads on the transistors are correct. The integrated circuits don't melt down. We build a controller that will work. At that point, we have to step up at the table, gentlemen, and pay for it. That's what your money's doing. We've got everything else we need.
I mean, it's 3.5 years of research at full time here.
And I've been on it for a lot of years too. But getting back to it, the other part of the commitment that I asked Josh for was so that I could put in enough coin to generate the income he needs and I need so that we don't have to work and we can finish the project in less than 6 months. We don't want this thing to last more than 6 months. We've got other things we want to do. And the other excess on that other end that's on my end is for 3 things. I'm going to be buying the extra equipment we need to make this work because we're moving to a different shop. There's not enough room in here for us. Not the 2 of us anyway. We need a couple of what we call high frequency, high voltage oscilloscopes. Those things ain't cheap. Okay? We need 2 of them. We're going to need to build a new splitter. One that's built to augment all of the capacitance that we're going to use and how we're going to use it. That splitter I've got my elbow on. This is one he made himself. It's rudimentary at best, but I guarantee it works. It's used to chop the voltages and spikes out of voltage. I don't need to go into that to you. It's a lot of theory. It's just one of the pieces of equipment we need to design and build. Another piece that we're going to need for this, and this is probably going to be the most fun building, is the 5 kVA cans I told you about. We don't like those designs. Neither one of us do. We know that we can build a better one for about 1/3 of the space. At that. And this thing will be just as cool running.
Is right here.
There you go.
That's what we will replace the can. It's going to be an open coil.
But in a different configuration where it's safer.
That's right.
But this coil replaces that 5 kV can. Now I know you're going to simply say this is way too much information, it's going to drive you nuts. Just suffice to say that we have a way to make this into a different configuration that will take place of that 5 kVA can. I wish I had one here to show you, but I don't.
Well, the can is right. We have a can. It's just buried in my strap here. So that's the motor's right here. That's
Okay.
that's a 10 kV. Right. I'm just gonna move. I'm just gonna move you so you can see that can there. So you see it there a little bit. Here, I'll move that.
Take
There
this
we go.
off. There's a 10
That,
kVA.
that's a 10 kV. That transformer is probably as old as I am. It's a multi voltage 772.
What he means is this can run a single 120 line, 120 volt line, or two 20 volt,
That's correct.
120 volt lines. It's rated for 144,400 volts or 7,200. 7,200 runs the 120. Okay. Don't look at this and expect this to be something somebody's going to have in their household. This is the unit and how it works. This is the concept. It doesn't prove a thing. This is just what it is. The unit we build is a box. It's going to be about this tall and about that square. It'll be about like that. It'll be roughly 9 inches, maybe 10 inches across, maybe wide. Wide width, it'd be about 8 to 9 inches wide, and it might be about 12 inches tall. Now, you're going to simply say to yourself, that doesn't sound like much, but it is. Gentlemen, I worked overseas on some of the largest power plants in the world. 125 megawatts. Breaking the power on that between the transmission line and the transformers is enough to arc 6 feet in the air. Guarantee you anything that's able to be ground is going to receive that arc and be vaporized instantly. The switch gear, which we call switch gear, is the switch which breaks that contact between those parts. And that switch gear usually in any power plant is embedded in argon gas. So when the arc happens, at least it doesn't ignite the air and cause a problem. A company in Germany built a particular switchgear that we used in Saudi Arabia. Every one of you probably have a pizza cutter at your house. If you got two, you now have the knife blades that are inside that stupid switchgear. There are 5 pizza cutters that come together like this and expand away from each other inside an arc-on tube that is exactly 6 inches square by 12 inches tall. And we arc 120 megawatts out of that box. I brought this to your attention because of the fact that size is not important. What is important is how it's put together to do its job. The 5 kV can is as tall as this. It has a single pole on it. It's a round can. You can see one on the top. It weighs, I think they weigh about what, 175, 200?
Oh, they're 5. Yeah, they're about 175 pounds. That one behind you is about 400 pounds.
Yeah. The 5 kVIs are 175 pounds. When we put this together on a pad that's 4 foot wide, 6 foot long, with the motor, generator, transformer, power leads back into the house, you're talking about 3 components that plug together kind of like that. And you buy it as a unit. It comes out shipped with instructions. You put the motor down, you mount it and screw it into the tab. You take the generator, slide it in, couple it, bolt it into the pad, and then you set the transformer on the outside and you bolt it down. You take the insulated wire hangers that are going to go over this big huge wire that we got and encapsulate it in some very thick resistant plastic that's bolted together, so like I said, a child with a golf club can beat on it all damn day long and it won't shock them, it won't break it, it won't cause a problem. We want this super safe, obviously. Then the two power wires that come out, the instructions are to take it out to your house, throw your 100 amp breaker underneath. The power comes in to your house. It's not the power, or sometimes the power comes down. It's wherever it comes into the 100 amp breaker. Okay? You will have called the power company and told them to switch your power off. You take your hex heads, open them up, take those 2 wires, pull them out, set them aside. We'll provide caps to go on them. They're plastic caps. Put the plastic caps on them. Bring your wires back into those positions, lock them in, and then we're going to give you a set of capacitors. That capacitor set is what kickstarts this motor. You're in the jungle, or you're in some place, or you're in the middle of North Dakota. You have no power, but you've got one of our units sitting on a pad. You take your capacitance set, you take the wires off the box, run it over to a special connector that's on the side of the motor, clip it in, there's a switch on it, you go click, your motor starts, it runs itself, produces power, and it recharges your capacitance bank that's sitting there. Guess what? You never have to turn it off. But if for some reason you could stall that thing and stop it, those capacitors are recharged and ready to start it again. It's a foolproof system. Give us the money to make our controller. We'll give you a motor that you can drive a bus with, or a truck, and might even be able to train a lot better than what they're doing now. Think about that.
Because we don't have to do much on the train. They already electric.
I know. But if you put one of our motors in with our torque, we'll be able to develop a 1,000,000-pound torque in a smaller package. Less heat, less power usage. They don't need those great big generators sitting on the back of them anymore. Think about that, gentlemen. We have a very unique opportunity. We need your money to kickstart to get the first part going. That's the gist of our presentation. We believe that if we showed you this before we gave you a business plan, you'd understand it. The business plan is very simple. We're going to buy the off-shelf parts that we need to put this together at bulk rate pricing. Why? Because that's the simplest way to do it. We don't need to reinvent the wheel on a lot of this stuff. The pieces that we need reinvented, we're going to do by having it done job shop wise. In other words, the winding for the motors will have a schematic of how we want it done. All the guys are going to do is take their programmable wrapper winders, put in the coordinates for the first turn. It does the rest automatically by itself. At that point, they're being wound the way we want them. We will field check them to make sure they're done, obviously, because I inspect what I expect. If it isn't that way, it doesn't work that way. Now, once we've got those wound the way we want them, both generator and motors, the magnets. We know the sources to get our magnets. We can get magnets polarized in any configuration we need and at a reasonable price. Now, that in itself should intrigue you. I want you to picture in your mind, can I have your cylindrical magnet over there, please?
The cylindrical one?
Yeah. I want you to picture this magnet in your mind. Go and buy it anywhere. You've got a north, what they call a north side, and a south side. Have you ever seen a magnet, a round magnet that has a north side and a south side, like this? No, you haven't. But we do, and we can have it made. Part of the configuration we want for a certain type of device. There are many things that we're bringing to the table that we would love to explain to you, but to be honest with you, it's overkill right now. What we wanted to do is prove to you that we've got a generator here, hooked to a motor. We've cross-phased it, short-circuited it for all intents and purposes, and it would run till hell freezes over and won't burn up because of the way it's wired. We intended to get rid of the one thing that kills all generators in America or anywhere else in the world. It's called heat. If you can't heat up the windings, you can't burn the generator. If you can't heat up the windings, you can't heat the bearings, which then burns up the generator. If you can't heat the windings, to heat the bearings, to heat the shaft, which warps it, you can't burn the generator. These generators won't burn up because of heat. Tampering with it? Yes, you can destroy it tampering it. And remember the act of God? If God wants to shoot his lightning bolt through it, or if there's a static discharge of 1,000,000 volts or better in this area, it's going to do something that you already know about. It's called an EMP. That EMP plunge is going to fry every circuit in our controller, and our controller's not going to work. Those are the three things that can happen. Now I want you to look at $7,500 to have one of these on a pad, plus another maybe $1,500 to pour the pad and put a nice cover over it.
The insulation.
Insulation, you're looking at about $9,000. In your minds, take $9,000 and divide it by your average electric bill, and please tell me yourselves, when will you be having free power in your house? I think you get the point. Thanks for your time to look. Thanks for your time to listen. Please consider it. We need your money, but more importantly, the world needs our products. Thank you for your time. We brought you back. Sorry, there was a tiny one thing that we skipped in our demonstration that we needed to show you. Remember, I was trying to prove to you that If you can see it works, you can believe it. If you can conceive something, that's one thing. If you perceive it, it's another. But if you actually see it working, you can understand it's believable. It's not too good to be true. What we're going to demonstrate is the safety of this system. And this is one of the things we wanted to show you. Gerard's going to turn this thing back on again. Remember how we started it? Our little battery-operated power controller. We're going to put a light over here, a cover over
so
the
you
light.
guys can see. Now,
Turn it up a little bit so it's a little bit brighter.
it's always maximum already.
Okay, it's already at maximum.
So the light is full bright, as you know.
Remember, this is a 240. This needs 240 volts at 2 amps to fully operate. If you had your hand on here, you could feel just a tiny bit of warmth. Not much. The glass is still cold to touch. It's not because it just turned on. It's because it's not generating heat. Now, in a minute, he's going to do something that's going to blow your mind. Remember these two things right here? We shorted out. We left it shorted for over, what, 5 minutes to prove you couldn't burn it up?
Almost half an hour.
Almost half an hour. There you go. Go ahead, show them.
Well, normally when you create AC current, right, you wouldn't be able to touch one wire. I mean, if you plug that and you touch one wire, you're going to be,
Sitting on your butt.
sitting on your butt, winding for pains. And never mind touching 2 wire, right? Now I'm holding the 2 wire, which lighting up this light.
I'm going to cover this.
Okay, now we got
Turn your hands so they can see them.
2 wire, I'm holding it. Matter of fact, I'll put some conduction. Okay?
Now, he's not wired half-assed. I can touch the same wires. It
Yeah.
won't do a damn thing to me either.
Exactly. Because the power goes through you, not on as a...
We're not a load.
Yeah, we're not a load.
This is the load.
Yeah.
This is the appliance that's using that power. Because it finds its avenue of least resistance, it's going there. It's not going through us.
Now, I might be half dead, so he's going to do it.
I've got a hold of it.
And he's
can
still
see.
alive.
I'm standing here holding
His
it.
hair is not standing up. You can't tell mine, but
Am I stuttering yet?
not yet.
Shit. Any rate, the point we're getting at is this. Gentlemen, no one wants to invest their money in something that doesn't work. That is the stupidest thing that you could do. We've proven it works. Please understand that. Proof is in the pudding. Talk is cheap. Proof is in the pudding. There it is. It's working. And this is not the unit we're going to be using. But we've shown you how we can modify this unit to develop such horsepower in a small package that's unbelievable. I've told you that one about 6 times this size could go in a bus. That bus will never stop. It'll run forever, never using another drop of fuel.
Yeah, grease.
Okay, grease for the bearings. They gotta be lubed.
In a little bit, yeah.
I told you that we're going to talk to you later on about the car. We do have a concept for a car, believe me. Whether or not we want to do that is up to you guys. Understandable. You're the ones that are coming in to finance things. We'll explain it to you if you're interested later on. Right now, we've got this project. We want this done because this will give us the foothold to move on the other ones. I hope you will have many questions. I hope that you'll come to us with lots of them that we can get to you and answer for you because that shows you're interested.
And they can feel free. If they want
Yeah.
to put their hand on it, grab the wire themselves to be a believer or not. I had many physicists who came here. They look at it. I even challenge every people who had knowledge about electricity to come and prove me what I was doing was wrong. And every time someone came here, they walk out of here with their jaw drop and shaking their head. They don't understand what is going on.
And again, please understand something. My definition of the difference between ignorance and stupidity is this. I don't know how to make an atomic bomb. If I did and made one, that would be plain stupid. But I'm not stupid enough to say it doesn't exist. Why? Because it's been proven. Case in point. Gentlemen, we thank you for your time again. Please consider it.
Thank you.
Have a great day.